Hello everyone, NeuroLars Hands here, and today we're going to see if we can recover this heavily sulfated lead-acid battery. I've done a video previously on how to properly desulfate batteries. If you haven't seen that, I'd encourage you to watch it. But before we get started, let's first see what we have. This is a Liach, I don't know what that is, some brand of AGM non-spillable battery. This is the kind that you typically see in computer UPS units. I don't know what it came out of. I actually don't know its history. But it's a 12 volt battery, 7.2 amp hours. Gives you some charging information on here. AGM is absorbed glass matte, so it's non-spillable. I don't know what the state of the water level is inside. You can't really inspect that in AGM batteries. They're sealed valve regulated. And some people say you can pop this top off and add water. There's some reasons why I wouldn't recommend that. It's easy to overfill them. But anyway, I'm not going to do any of that. We're just going to see if we can recover this thing as is. Now the first step, I suppose, would be to check the voltage on it. So just get a generic multimeter out here and see what it is. It is 390 millivolts, 0.4 volts. Obviously that is bad. Now batteries like this typically can't be recovered, but we're going to give it a try anyway. Again, I have no idea what the history of this battery is. It was just in a pile of old dead batteries that were out for recycling, and I thought I'd just give it a try. It's possible that this battery was in a UPS unit and the water all dried up inside it. If so, then I'm not going to be successful recovering this. But it's also possible that it was in another application or just sitting on a shelf and stored dead and it was heavily sulfated. So let's first see what we can do to get this thing charged. Now, in my video on how to properly desulfate batteries, I use something like this, just an old school dumb charger. I used that at that time because these were easy to find back then. Since people have notified me that it's almost impossible to find standard old dumb chargers, they're always microprocessor controlled now, and those simply don't work for this sort of thing. I'm not going to use any special equipment for this in terms of desulfating batteries. What I'm instead going to use is some equipment I haven't shown in any other videos, which is just a basic lab style power supply. This is a 30 volt 5 amp power supply. It's a Corad brand. It works okay, but it doesn't actually do 5 amps. It overheats if you do that. But anyway, let's first see if this battery will take a charge at all. We'll see what the voltage rating on the battery is here. Standby use, float charge to 13.5 to 13.8. Cycle use, charge at 14.4 to 15 volts at less than 2.16 amps. So those are the instructions on the battery. Hook it up to my charger here, and I'll turn the voltage down to within range of what it's supposed to be for this battery. And hook it up. And unsurprisingly, you can see that it is consuming almost no current. Now, these batteries are typically pure lead, or they are lead calcium. They're usually not lead antimony, but I don't actually know what this one is, or if the manufacturer even says what it is if I look it up. No idea what this company is. But anyway, on a lead calcium battery, if it's fully discharged, it will refuse to take a charge for a while, and with time, the current will start ramping up. A heavily sulfated battery requires a lot of voltage to push current through it. So, despite this battery saying that it should be charged at less than 15 volts, this is a 30 volt power supply, and how about we put 30 volts into a 12 volt battery? That seems like a good idea, right? Let's see what that does to our current. There we go, 31 volts, and still no current. So I'm going to let this sit here for a while and see if this battery starts accepting current. If it doesn't, then, well, it's not going to be coming back. But I'm just going to let it sit here for a while. It might take quite a while, it might not, I don't know. And I'm going to limit the current here to, we'll say, 2 amps. So if it hits 2 amps while I'm not watching it, it'll stop at 2 amps. Otherwise, it'll use up to 31 volts to try to force current through this battery to desulfate it. Now in my other video on how to desulfate batteries, I just used a standard old dumb charger like this. They're very hard to find now. Almost all of them are microprocessor controlled and they don't really work for this sort of thing. Even the ones with a desulfation mode, in my experience, are non-functional for this sort of application. So it's kind of unfortunate, but if you can find an old used one of this, you can still use the method that I showed in my how to properly desulfate batteries video. But in this case, I'm just going to use this method. These lab power supplies, you can get them pretty cheap. You can get them for less than $50 now. We'll just keep this on the charger, and you can see that the current's starting to ramp up, so it is kind of working. It's working at those lead sulfate crystals in here, turning the plates from a non-conductive surface into a partially conductive surface. And we'll just let this go and see how it works. One thing I wanted to address is safety. I suspect one of the primary things people are thinking right now is, why in the world are you putting 31 volts into a 12 volt battery? And is that safe? Well, I mean, there's lead in here, that's toxic, there's acid, that's corrosive. It does produce hydrogen gas that can explode if you overcharge it. So yeah, bad things can happen, but overall this isn't terribly dangerous. But 31 volts, well, it doesn't really matter what voltage I set it to. What matters is how much current is going through this battery. And right now it's less than 0.1 amps. So 0.1 amps times 31 volts, that's 3 watts. This battery can easily handle 3 watts. And when it comes to hydrogen gas production or water loss in your battery, that's directly proportional to the current that you're pushing through it. If the current's going into charging it, it won't produce gas. If it's going into waste heat, it will produce gas. So that's why I had set the current limit to 2 amps, which is actually what this battery is rated for. So that should be a safe level for this battery. But I'm going to let it sit here for a while and turn the camera on every once in a while to see how it's going. As a matter of interest, some of you who maybe subscribed to my channel a long time ago might be wondering why I'm not really making videos anymore. Well, I don't really have a good reason for it. I guess I made videos for a long time, kind of got burned out on it, and then various things happened in life that made it very inconvenient for me to make videos. So this is a tiny little room that I have right now where I'm storing a lot of my stuff. I have all kinds of project ideas and stuff from this room. There's my batteries for my 1000 amp hour battery bank. I have some more lab equipment scattered around randomly, some inverters here and there. But anyway, this is a really messy room, and it's just not very fun to work in. Of course, I could clean it up, but meh. Oh yeah, and I have a cat who really loves to get into all of my stuff. And it's really, really fun. Everything I do is fun. So when I'm doing dangerous stuff, that's also a bit of a problem. Bye-bye. Well, it's been about 10 minutes, and we can see that we're now pushing 0.2 amps of current through this battery. So it's actually doing something, which is pretty good for a battery that was at 0.4 volts to start with. Now, you might notice that this current will go up and down at certain points during this desulfation. That's just because it gets more and less conductive. It might burn through a bit of sulfation. It then charges a portion of the plate. That portion of the plate's then charged and highly resistive, so that portion of the plate's then fully charged and is now acts as a resistor, so then the current goes back down. In general, it should continue creeping up. As long as it does, then this is still working. So just out of interest here, I want to check something. We'll turn that off. Turn our voltmeter back on. And let's see what the open circuit voltage of this is now. 10.6 volts. So it's definitely doing something. Normally if you put a battery on a charger like this and it still only reads 1 volt, then you're just wasting your time. It looks like this one might actually come back. I'll stick it back on the charger and continue. With the charger, you know, a dumb charger like this over here, this process might take days. You have it sit here on that charger for days. This speeds it up significantly, only because it's a much higher voltage. But it doesn't really work any better, it's just a little bit faster. It's been about 15 minutes. We're now pushing 0.35 amps through the battery. And it's starting to rise a little bit quicker now than it did initially. But I'm getting bored. Yum. That's good stuff. Now, this isn't really something I'd recommend just leaving out and abandoning, at least not with these settings, because you can cause damage to the battery or even have it burst and leak acid all over. And there's a few reasons for that, but mainly this is 31 volts. When this gets up to 2 amps, that could be 60 watts of power that you're dumping into this battery, and it can't handle that if it's dissipating it and not charging. Now hopefully what happens here is once this amperage goes up enough, this voltage will start dropping, and that's because the resistance of the battery is getting lower and lower as it desulfates, and eventually this battery, if it can recover, is going to be accepting that 2 amp charge at a voltage of 15 volts or something like that, and at that point you're not producing a lot of heat in the battery. But none of that stuff really matters too much. What does matter is just feel the battery. If it feels hot, you got to back off. I have this infrared camera here, infrared thermometer. I'm just have it in Fahrenheit here, but you can see that it's not at all warm yet. This particular battery has 1, 2, 3, 4, 5, 6 cells, so you'd have to measure both sides of the battery. But in any case, once it gets warm, then we have to start worrying about that. Right now, it's not a concern. Out of curiosity, I went to their website, and it turns out that this is a very reputable battery company, and I found a data sheet for the exact battery that we have, with a bunch of good information in here about the capacity at different discharge rates, dimensions and whatnot, discharge curves, all kinds of stuff. So there's some pretty good info on this battery, and if we manage to recover it, we'll see how this compares to how it actually performs. In particular, this discharge curve here. It's been about half an hour, and the current just surpassed 1 amp. And the battery is starting to get a little bit warm now. And the current's rising fairly rapidly now compared to how we started, so I'll keep an eye on this and come back occasionally to check on it and see how it's doing. I did notice that on this side it looks like there's some label damage and there's this sticky stuff, so this definitely came out of a UPS because this is how they package those batteries. I don't know exactly what was going on. We'll just see if we can recharge this or not. This is now rapidly reaching the 2 amp limit that I set, still at 31 volts. It's warming up quite a bit, so I might have to back this down. Right now the internal resistance is extremely high, and that's why it's requiring 31 volts to put 2 amps of current through it. And there we go. It's gone into constant current mode. And the voltage should start dropping. It's only been about 5 minutes since it hit 1 amp, so it's definitely accelerating. This is the warmest cell in the battery. It's 100 degrees. I'll have to monitor that. The rest of them are not very warm at the moment. And one thing that's kind of interesting to me is that the temperature of the cell from bottom to top is roughly uniform. And that's also a good sign, because the recombination of the electrolyte normally only happens in the very top portion, the portion that's not saturated with water. The glass mat in the bottom portion is saturated with water, and then there's a portion of glass mat that is not saturated with water up here. That's where the recombination happens of the oxygen and hydrogen to turn it back into water, which is what makes these so efficient when it comes to water use. That recombination is the thermal generator, so normally these batteries would get hot where the recombination is happening, but this one's being evenly warm all over, which either means it's almost completely out of water, which is bad, or it's almost completely full. So I'm hoping that's the case, but we'll let this run and see what happens. It's been a total of 45 minutes, and this battery is already almost down to a normal charging voltage for 2 amps. That's still well above normal, but much better than 31 volts. And the temperature of this hot cell has stabilized. It's no longer rising. So it should start falling once the voltage starts falling. When you're charging a battery like this, the 13 volts or so that you're sending through the battery goes into the actual charge of the battery until that cell is full, and the remaining voltage gets converted to heat. So if this was 13 volts, that'd be 5 volts times 2 amps. So that's 10 watts of heat that we're putting into this battery right now, assuming that it's actually charging. So it's much better than it was before, and I'll just keep monitoring it here, and hopefully that voltage keeps decreasing. It's only been 1 hour, and our desulfation attempt is going extremely well. This is at 2 amps still, and the voltage has dropped all the way down to 15.6 volts, and it's still dropping. The battery temperature is actually started to fall now. This is still the warmest cell. The rest of the battery is getting warm now. So we're not going to run into a thermal runaway situation. At this point, just out of interest, I just wanted to kind of play with the controls here and see what happens. So right now it's at 2 amps. Let's see what happens if we bump the current down to 1 amp. 14 volts. So a normal charge voltage would probably be somewhere in here at the capacity level, the charge level that this battery is at, state of charge. So we still have a very high internal resistance on this battery, but it's getting lower and lower and lower. And now, just out of curiosity, what happens if I crank this all the way up to 5 amps? Well, we're only at 20 volts. That's not so bad, really. Alright, so now I want to check the open circuit voltage of this battery. So let's see what we have there. And our open circuit voltage is 12.3. It'll keep dropping over time as it sits here, but that's indicating that we're being quite successful. So 12.27 volts here is definitely a partially discharged battery, maybe about 50% state of charge. We've put in maybe about 1 amp hour of charge into this battery so far. This is a 7.2 amp hour battery, so we have a long ways to go, and who knows how much it'll actually recover. It might only accept a few amp hours of charge once this is all over with. I'm actually going to bump this current up to 3 amps for a while and let it go. It's now been 1 hour and 20 minutes, and even at 3 amps, we're only at 15.5 volts. So this is looking very, very good. Also, the battery is still cooling off. I turned off the charger and got something to eat. It's been probably a couple of hours just sitting here, and it's cooled down to almost room temperature. Let's see what the open circuit voltage is now that it's had time to settle. 11.76 volts. So this battery is still very, very dead. It's maybe 20% state of charge, something like that, pretty low. And time to put it back on the charger. I'll set it for 3 amps and let it continue. Within a couple of minutes, the voltage stabilized at about 15.3 and has started to drop. Now, at 2 amps for that state of charge, this battery probably should be at about 13.5 volts, so it still has a very high internal resistance. We'll see if we can improve that by keeping it on the charger longer. The battery's been charging at 3 amps for a little while now, and I just wanted to point out something interesting here. So, if I bring the current down to 0 amps and let it settle out, it ends up being at 12.5 volts or so at no current. If I bring it up to 1 amp, it's at about 13.3 or so once it stabilizes. 2 amps. It'll end up being about 14.3, and 3 amps, about 15.3. So you can see it's pretty much linear with respect to the voltage, and that's because this battery still has a pretty high internal resistance. And as it charges, that should get lower if the sulfation gets broken up, and a properly functioning battery will have a voltage that is only slightly dependent on the current. But right now we get about 1 volt per amp, and with Ohm's law, volts over amps equals the resistance. So 1 volt per amp, it's about maybe 1 ohm on this battery, which is really, really bad. So we'll let this continue and see if we can improve that. Well, some good news and bad news. It's been another 15 minutes or so, and you can see that we're now at 16 volts at 3 amps. So while this battery is accepting a charge still, its internal resistance is not decreasing as fast as it is charging. So good news, it's charging. Bad news, its internal resistance isn't really decreasing. But another thing that's kind of good is this cell used to be the warmest one. Now it's barely warm at all. And some of these other cells are warm on both sides of the battery. So it seems like we're improving all of the cells not just this one. The 3 amp charge voltage has continued to climb. It's now 16.2 volts or so. But I wanted to point out one thing at this point. If I take my current and I bump this down to 0, you can see that the open circuit voltage of this battery is about 13.5 volts. Now, on a fully charged battery that just got taken off the charger, this should be around 14 volts or so. So because this is still low, it tells me that this battery is still fairly sulfated. And if I let this sit open circuit for a long time, I bet this would be 12 point something volts, quite a bit lower than this. So it does still need to be charged. I'm going to leave it on the charger for longer and continue from there. Well, the battery's continued to accept a charge. It's been maybe half an hour now, and it's still accepting 3 amps, but at 17 volts and rising. The temperature is 110 degrees or so on the warmest cells. And I think I'm just going to turn off the charger and let this sit and see what happens. So if I turn the current down, the voltage drops pretty quickly to 13.8 volts or so. Continues drooping from there. So it's getting better, but I just want to let this sit for a while, and I'll check it tomorrow sometime and see what voltage this battery is open circuit.